The logarithm of a number to the base 10 has two parts. So here the integral part is called as the characteristic, the other is the fraction part called as the mantissa. Log of 337.6. So how many digits are here? 3 digits. 3 minus 1 equals 2. So 2.5284. Anti-log value of 1.2456 is 17.60. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. So we all know that logarithms are of two types. One is the natural logarithm, the other one is the common logarithm. So logarithm to the base e are considered as natural logarithms and logarithm to the base 10 are considered as a common logarithms. Now let us have a look into what are the common logarithms. So by the definition of logarithms, consider the following examples. Now suppose I have given you 10 to the power 0. The 10 to the power of 0 is 1. But then log of 1 to the base 10 is always 0. Next, 10 to the power of 1 is also equal to 10 and log of 10 to the base 10 is 1. So why log 10 to the base 10 is 1? Because log of any number to the same base is always equal to 1. Then 10 to the power 2 equals 100. So log 100 to the base 10 is 2. 10 to the power 3 equals 1000. So log 1000 to the base 10 equals 3. Now if you observe this, the log values between 10 to 100, it lies between 1 and 2. So all the numbers, all fractions, decimals, everything, so it lies between just 1 and 2 and the log value of 100 and 1000, it lies between 3 and 2. Okay, now log of 0.1 to the base 10. What is log of 0.1 to the base 10? So in other words, so I can write this 0.1, it can be written as 1 by 10. So this is 1 by 10. Log of 0.1 to the base 10 equals minus 1. So why it is minus 1? Because the power is minus. When the power is minus, we just bring this 1 by 10. So we write it as 0.1 is, you can just see this. So it will be 1 divided by 10. So it does not go 0. Then 10 ones are 10. So this is 0. So 0.1 is the answer. Now 10 to the power minus 2 equals 0.01. So when there are two zeros given here, so 1 0 is to the left hand side, 1 0 is to the right hand side, the value is minus 2. The same way, when there are 3 zeros in the given value, then we write it as minus 3. So in this way, we should understand that all the log values between 10 and 100, they lie between 1 and 2, and all those values which are between 2 and 3, they lie between 3 and 2. So the minus values, or the decimal values will have minus along with the value. Now, the logarithm of a number to the base 10 has two parts. So here, the integral part is called as the characteristic, the other is the fraction part called as the mantissa. Now, suppose the log value of 25.63 equals 1.4085. Now, this 1, this we call it as the characteristic, and this decimal points, so we call it as the mantissa. So here the characteristic 1 is the characteristic and 0.4085 is called as the mantissa. Now in this table we can just see here they are given the various log values. Suppose I have to find out the value of 34337. What is the log value of log value of 3437. Suppose I am given a number, find out the log of 3437. Now what should I do is, I should count the number of digits in the number. So in this number there are 4 digits. So 4 minus 1. So 4 digits minus 1. So I write it as 3 point. Now 3437. Now in this table 3, 4 is there. Then I'll see here third row. What is the value here? 5353. Then what is the next value? 7. So this 7 I will be seeing it in the same row but in this column. 9. So I'll write this 9 here. So 9 plus 3 is 12, 1, 6, 5, 3, 6, 2. So this the value is 3.5362. So this is the log value of 3437. Suppose I am asked, find the log of 34.37. What will be the answer? So there are 2 digits to the left of the decimal point. 2 minus 1 is 1. So the characteristic will be 1. Now again I will have to see 343. So again 5353 plus 9, 5362 I am getting. So I will write here. So 1.5362. See, when there are no decimal points, the value is 3.5362, but when there are only 2 numbers before the decimal point, we get 1.5362. So this is how we will have to find out the values. Suppose I say log of 3.437. How will I find out the value of this? So how many digits are there to the left of the decimal point? Only 1. So 1 minus 1 is 0. So 0.5362 will be the answer. So in this way we have to find out the log values. So when the given number is of 4 digits, then the characteristic will be 3 point the log values. Suppose they are given only 2 digits, 2 minus 1 is 1, 1.5362. Then if there are only 1 digit, 1 minus 1 is 0. So 0.5362. So in this way we have to find out the log values. Now in this here, if you can see here, log of 33.76. So the value comes up to, so there are 2 digits here, 2 minus 1 is 1. So 1.5284. Then again here, log of 337.6. So how many digits are here? 3 digits. 3 minus 1 equals 2. So 2.5284. Suppose there are 4 digits, then it will be 4 minus 1, that is 3.5284. So 0.3376. So there are no digits. So I will write it as 1 bar. So this is spelt as 1 bar. Or this is a negative sign. Okay, then log of 0.0376. So there is 1 0 here, 1 0 here. So that will be 2 bar. So I can write it as 2 bar. 2 bar 0.5284. So this is how you will have to work out the problems. Now here if you can see here, we have the anti-logarithm. So once you find the logarithm values, then again to convert it into the original number, we have to find the anti-logarithm of the log. So when you have this anti-log, with the help of anti-logarithm tables, we will be able to calculate the values. Now suppose, so anti-log of 1.2456. Now anti-log of 1.2456 is 1760. Now how do we find out the value of this? So we go back to the, so 1.2456. Now anti-log of 1.2456. Now, when we have to find the anti-log of this, I will take the values from 0.24. So, 0.24 is here. So, 0.245. What is the fifth value tell us? 1758 plus 6. So, under that mean difference 2 we will see. So, 8 plus 2 is 10, borrow 1, 6, 1760. So, anti-log of 1.2456 is 1760. Now, see the number, count the number of digits to the left of the decimal point. To the left of the decimal point, we have 1. 1 is written. So, 1 plus 1 is 2. So, after 2 numbers, I put a decimal point. So, this is the value. Anti-log value of 1.2456 is 17.60. Now, I will give you one more example. So, in this example, suppose I write, find out the anti-log of 1.2157. Anti-log value of 1.2157. So, what should I do first? I will see the 21. Where is 0.21? 0.21 is here. Now, the fifth column, 1641. 1641 plus 7. It is 3. So, 1644. So, I write it as 1644. Now, there is 1 written in the characteristic. I will add 1 to the characteristic. I get 2. So, after 2 digits, I will put the decimal point, 16.44. So, this is the answer. Given anti-log, we will have to read the table from the decimal point. To the right hand side, what are the numbers? Only those values we have to see, and then we have to insert the decimal point depending on the number in the characteristic. Now, next. So, I have already explained this. Now, let us work out a few problems on these log values. Now, find the value of each of the following using logarithmic table. So, the given problem is 12.56 into 10.73. Now, I will write here, let x be equal to 12.56 into 10.73. Now, taking log on both sides, I get log x equals log of 12.56 into 10.73. Now, I will use the laws of logarithms. What does the law of logarithms say? Log mn equals log m plus log n. So, here I will write it as log of 12.56 plus log of 10.73. Now, find the value of log 12.56. How many digits are there here? So, 2 digits. So, I will write 1 point. Now, I will have to find the log value here. So, log value of 12.5 I have to see in the log table. So, in the log table, I have to see the number 12. So, 12 comes up to 0969. So, 0969 plus 1256, 21. So, 21 I add it here. 9 plus 1, 10, borrow 1, 9, 9, 0. So, 0990. So, I will write it here 0990 plus log of 10.73. Now, I have to see the number of digits to the left of the decimal. So, how many digits are there? 2. 2 digits. So 2 minus 1 is 1. 1.107. What is the value of 7? 0294. So 0294 plus 3. 0294 plus 3, it comes up to 0294 plus 3, 12. 4 plus 2, 6, 9 plus 1, 10, borrow 1, 3, 0306. Now I write it here 1.0306. Now add these both the values. So I will add it here 1.0990 plus 1.0306. Add both 10, 11, 12, borrow 1. So this is the answer. So this will be log x will be equal to 2.1296. Now we have to get back the value which we have started. Now I have to find out the anti-log of this. Now anti-log of 2.1296. Now if I go to the anti-log table, I will be just searching under 0.12. So what is the number given here? 0.1291346. So 1346 plus 2. 1348. So anti-log of 2.1296 will be equal to 1348. Now you see the characteristic here, it says 2. If it is 2, I should add 1 to this 2, so it becomes 3. So I will put the decimal point after 3 digits. So 134.8 is the answer. So this is how we will have to solve the problems based on logarithms. So we have made use of the log table and found out the value of 12.56 into 10.73. Now here if you can see here, so 0.632 into 5.673 into 0.3213. So let x be equal to 0.632 into 5.673 into 0.3213. Now taking log on both sides, I will get log x equals log of 0.632 plus log of 5.673 plus log of 0.3213. Now we have to find the log values of 0.632. Now when I have to find the log value, I will have to see how many numbers are there behind that is to the left of the decimal point. So there is only 0. So 0 minus 1 is 1 bar. I write it as 1 bar. Then I find out the value of 632. Now I will take the log table and I will just say 632, 63 and 2. So this comes up to 8007 plus 632, 8007 plus. Now log value of 5.673. So there is only one one number to the left of the decimal point. So 1 minus 1 is 0. I will write 0.5673. 0.5673. I will just see here the log values in this log table. Now we will find the log value of 5.673. So that will come up to 7536 plus 7536 plus, so it comes up to 7538. So 7538 plus, so there is log of 0.3213. So 0 minus 1 is minus 1. So whenever there is minus 1, I put it as 1 bar 0.3213. So 32. Now what is the value of 32? 32 is 321. 50321 is 5069 plus 4. 5073. 5073. Now we have the log values with the help of these log tables. Now I will have to add all these values. So I will get, so then a working column I will add it here. So 1 bar 0.8007 plus 0.7538. So what is the value you are getting? 7 plus 8, 15, 5 borrow 1, 4, 5, 15, 1 and 1 gets cancelled, 0 plus 1 bar 0.5073. 1 bar 0.5073. So this will be 5 plus 3 is 8, 7 plus 4 is 11, 6, 5 plus 5 is 10, borrow 1, 1 and 1 gets cancelled, so 0.618. So this will be equal to log of x equals 0.0618. Now we have to find the anti-log value of this. Now anti-log of 0.0618. Now I have to see the value from 0.06. Now I have to see the value here. So I am getting 1151 plus 2, I will get 1153. Now you see here the decimal point, to the left of the decimal point I have 0. So 0 plus 1 is 1. So after one digit I am just putting the decimal point. So the answer is 1.153. So this is the answer for this problem. Now the next problem, the problem given is 213.781 into 7.434 divided by 6.321. Now let us work out this problem. I will write, let x be equal to 213.781 into 7.434 whole over 6.321. Now taking log on both sides, I will get log x equals log of 213.781 into 7.434 whole over 6.321. Now when I take the log, so I can rewrite this as log of 213.781 plus log of 7.434 minus log of 6.321. 1. Now, we will find out the log values here. So, log of 213. So, there are 3 digits. When there are 3 digits, 3 minus 1 is 2. So, I will write it as 2 point. Now, I have to find the value of 2137. So, when I use the log table, I will be getting 2.3298. So, 3298 plus log of 7.434. So, the number of digits to the left is only 1. So, 1 minus 1 is 0. So, I will write 0. Then I find the log value of 7434. So, the log value, I am trying to find the log value of 7434. So, the value is 0.8712 minus log of 6.321. So, 1 minus 1 is again 0. Now, I have to find the log value of 6.321. So, when I find the value of 6.321, it comes up to 8008. Now, I am simplifying this 2.4002. How do I simplify this? I will add it here. So, 2.3298 plus 0.8712. 8 plus 2, 10, borrow 1. 9 plus 1, 10 plus 1, 11, borrow 1. 10, borrow 1. 12, borrow 1. 3.2010 minus 0.8008. So, now you simplify this. 10 minus 8 is 2, 0, 0. Then this will come up to 4, then 2. So, 2.4002. So, log x equals 2.4002. Now, anti-log of 2.4002. So, anti-log of this, you find out the value 0.4002. So, you will be getting, when we find the anti-log of 4002, I get the answer is 251. 2.4002, the anti-log of this is 2513. Now, you see the 2 is written here next to the decimal, left hand side of the decimal. So, 2 plus 1 is 3. So, after 3 digits, I put the decimal point. So, 251.3 is the answer. The next one. So, 0.5634, I will write let x be equal to 0.5634 into 0.0635 whole over 2.563 into 12.5. Now, when I take log, taking log x equals log of 0.5634 plus log of 0.0635 minus log of 2.563 minus log of 12.5. So, now we have to find the log value here. So, 0.5634. So, 0 minus 1 is minus 1. So, I will write it as minus 1 point. Now, I have to find the value of 5634. Now, what is the log value of 5634? So, the log value of 5634 is 7508. Now, again, to the left of the decimal point there is 1 0. So, I will write it as, to the left of the decimal point 1 0, to the right also there is 1 0. So, the value will be 2 bar point. Now, I have to find the value of 635. Now, the value of 635 is 8038. 2.563 minus 1 is 1. 1 minus 1 is Now 2563. Let me see what is the value of 2563. 4087 minus 1 point. So 125 is 0969. Now there are two decimals. There are 1 bar, 2 bar, and then we have this. So when we simplify all this, I will get now when I simplify this, I will get 2 bar 0.5536 minus 1.5056. Now when I simplify this further, I will get, now I am simplifying this. So 2 bar 0.5536 minus 1.5056, I will get minus 2 minus 0.0952. Now when I simplify this further, this will be equal to minus 3 plus 3 minus 2.952. So this will be equal to minus 3 plus 0.048. So the answer will be 3 bar 0.048. So this is the answer. Now when I simplify 2 bar 0.5536 minus 1.5056, I get minus 2 minus 0.952. Then when I have to take this minus sign, I will write it as minus 3 plus 3 minus 2.952. So when I simplify plus 3 minus 2.952, I get 0.048. So minus 3, I keep it as it is. 0.048 is the answer. So this is how we have to simplify this. Now the next problem here, let x be equal to root of 14.5 into cube root of 8.571 whole over 16.751 to the power of 2 by 3. Now this I will write it as, let log x be equal to log of 14.5 to the power half plus log of 8.571 to the power of 1 by 3 minus log of 16.751 to the power of 2 by 3. Now when we simplify this, I will get half log 14.5 plus 1 by 3 log 8.571 minus 2 by 3 log 16.751. Now when I find the log value of 14.5, so that will be 2 minus, there are 2 digits, so 1 point. So the log value of 14.5 is 1614. So into half. So this half I am writing it here, plus 1 by 3 into, so there is 1 digit here, 1 minus 1 is 0. The value of 8571 is 0.9331 minus 2 by 3 into log 16. So 2 digits, 2 minus 1 is 1 point. The value of 16751, that will be 2240. Now we simplify this further. So 1.1614 divided by 2, I get the answer as 0.5807 plus 0.9331 divided by 3, I get 0.3110 minus 2 by 3 into 1.2240. So that comes up to plus 0.816. So when I simplify this further, I get 0.0757. So 0.0757. So I have to find the anti-log of 0.0757. So that will be equal to 1.91 is the answer. So when you are having this problems like this, so with the help of log values, we can easily solve these problems. So log 14.5 to the power half plus log 8.571 to the power 1 by 3 minus log 16.751 to the power 2 by 3. So I bring this power to this side and find out the log value. So when I simplify this, the answer is 1.91. So this is the answer. With this, we come to the end of this session. Thank you.